Hello and Assalamualaikum. So this is presentation for BITI 3133, subject neural network, and the topic for the presentation is learning understandable neural network with non-negative weight constraints. Here is the list of the group members. First we have Fatin, Najdah, second Muhammad Syahir, and third Muhammad Anass. So for the first part, Introduction to Artificial Neural Network, ANN with R. ANN is a prediction model that has the ability to learn from examples. It consists of interconnected nodes in a structured layer. And if we want to implement this project, we need to implement it in R. And to use it in R, we actually need neural net library. Generally, to build a neural net model, we need to use neural net function, which the function itself is from the neural net library. So for the activation function, we will use SIG1Learning activation function, in which it will set the output to be binary numbers. So it's going to be either in 0 or 1. Thus, when we use the neural net function, we also can determine the number of hidden layers that we want for the neural net. And once the neural net has been fit by using the training data, we can plot the net by using plot command. And then after done with the training, we're going to do the testing by using the compute function. Next, step-by-step learning and analysis. For the first step, we need to create the data. In this case, we use our own data, but in certain cases, we can also use your own data from internet. And then for the second step, we must ensure that the data comprises of suitable observation, and for our case, we use 4 observations. And for the third step, we need to develop the model based on the data. Next, we put all together all the functions that we need to train the model, and for our case, we only need to use the SIG1Learning activation function. And then to determine the model's performance, we will use sum of squares error. So sum of squares error is a loss function, and the purpose is to select weights for each layer that minimize the loss function's outcome. And then we also need to use feed-forward and back-propagation in the code so that it can reduce the loss function outputs. Then we can observe the performance of the model using the loss function. And if the loss function values decreases as the iteration increases, so we can say that the performance of the model is good.
Okay, now for data that being used are composed of 4 rows of variables. 3 columns on the left are being denotes as the object and will be placed at x-axis, and the other column on the right that are denotes as the observed outcome will be placed at the y-axis. As you can see, we have provided the code at this slide. And then for the flowchart, for the first, we create a predictor variable and observe outcome, and then we print the data so we can take a quick look at it, and then we generate a random value between 0 and 1 each element in X. This will be used as our initial weight of layer 1, and then we convert a vector into a metric, then list source and the state of neural net as it trained, and then implement the activation function using SIG1Learning, and then we implement the loss function. Next, implement the forward and backward progression, and then the application of the chain rule to find the derivative of loss function with respect to weight and weight 1. Then we update the weight using the derivative slope of the loss function. Next, initiate number of time to perform fast feed forward and back propagation. Next, create data frame to store the result of the loss function. This data frame is used to produce the plot to the next code chunk. And then store the result of the loss function. And then point the predicted outcome next to the actual outcome. And finally, we will get the plot to desired output.
Okay, so for the next part, I will continue with the learning process. For the learning process, in every layer, which is in both input layer and output layer, the activation function, which is the CMOD activation, will be used and applied to every weight to update the weight. It is to ensure that it follows our title, which is we will add constraint to it, to all our weight to be non-negative. Then the code will train the data using both feed-forward and back propagation. This is to ensure that the loss function will be reduced. So for the final output on the loss function, the final output will be displayed in the plotted graph of x-axis, which is the number of iteration, versus y-axis of loss function. Okay, next for the data analysis with NNN models and their solution. The data analysis that can be obtained from our case study is that the data that is being used is created on our own in matrix form. Next, we will put the matrix form data into an object to hold the value that will be represent according to the neural network structure. First, we need to create the initial weight as if the input layer. To do that, the runIf command is being used to generate random number. Next, from the random generation, the representation is still a vector. It is not metric according to our dataset earlier, so we need to change it back to the matrix form. Next, the distribution of the value from the matrix will be according to their own location. So such as where is weight 1, weight 2. So yeah. Next is the explanation on finding figures and result. According to this picture, this is the graph of our output, which is the x-axis is the number of iteration and the y-axis is the loss function. As can be seen from the graph is gradually decrease until its limitation, which is 0. So we can gain the relationship of the graph is as the number of iteration increase, the number of loss function also will decrease. So the purpose of this output is to minimize the loss function in order to increase our training model performance. So as you can see, our output approve that, and this show that our model is accurate.
So now for the conclusion, we look at how restricting a neural network's weight to be non-negative impact the network accuracy and interpretability. The network understandability has increased. The proof can be seen in the final output, where the loss function become reduced upon increasing the iteration, and when the loss function become reduced, the accuracy of model will increase, and this will help other researchers to obtain a better outcome by using this model. That's all from us. Thank you.